Hey everyone, I built a unified APIs class which allows you to interact with any OpenAI, Anthropic, or OpenRouter model using a single Python class. This comes with many useful methods and handles message history and other useful things automatically. Each method comes with an async variant as well. We will be reviewing the code, but let's start with how we can use this with a simple example and with 6 complex examples, such as with multi-model chat, being able to use multiple models for a chat, model debating, where GPT-4, 3.5 Sonnet, and Gemini 1.5 Pro debate each other, coding agents, which plan among 3 models, and a 3 model response chat where we get responses in parallel from 3 models. Then a 4th model combines the best element from all responses. So this is like a 3 model response chat. Also, I built another one where we get parallel responses from GPT-4 3.5 Sonnet and Gemini 1.5 Pro, and another 4th model evaluates the responses. And also, I have one where we allow all models to evaluate it, and another version where a single model evaluates it. Code files for this will be available at my Patreon. The unified class plus the simple use case will be available at connoisseur level. All the full code files with the more complex examples as well will be available at Architect Plus level. Link will be in the description. So let's begin by demoing and seeing how it works. All we have to do is just import the unified APIs class from unified.py file and then initialize the class with, in the case we are initializing with Anthropic. By default, we are using GPT-4 Omni from OpenAI, latest 3.5 Sonnet from Anthropic, and Gemini Pro 1.5 with 2 million context window from OpenRouter. But you can use any models that are provided, that are from these providers. OpenRouter have hundreds of models, so check it out. You require API key for each one of these, and the system automatically detects it from your environment variables, or you can insert your key here. So you can define a provider model, JSON mode. Claude doesn't work with JSON mode, but OpenAI does, and you can actually name it as well. So it's just simply, it is a chat method, which we can send a message. So we can just right now talk to Sonnet, and that's it. So using the unified APIs, it's this easy to actually build chat applications or agentic applications, as we will see. We just switch to OpenAI, and we can now specify a model. But remember, GPT-4 Omni is default. Now, if we run the script again, we will be talking with GPT-4o. Here we go. You can change it to OpenRouter. Let's just remove the model because Gemini 1.5 Pro is the default. So when we run this, we'll be able to talk to Gemini. There we go. Now let's take a look at a more complex example, which actually allows us to choose the providers. This one was very easy as well. As you can see, we built it in under 50 lines of code. This asks you which provider you want to talk with. Let's select OpenAI, and then we initialize the class. You can see its details here, and then you can just speak with the model, and you can just say change and switch to Gemini, for example, by selecting OpenRouter, and then what did we talk about? And they all share a common history. Here, I asked Gemini to tell me a secret, and then I switched to Anthropic, and I asked, "What did we talk about?" It said that we said hi, and then that we asked it to give a secret. So this one actually keeps track of the history. But again, the history, it maintains the history across all different models. Again, all we had to do was import unified APIs and instantiate with the proper provider. And it automatically streams, by the way, but you can turn this off as well. And just call the chat async function. You can call the chat async or the regular chat. And that's it. And we then match their history. So this is very simple, as you can see. It makes it incredibly easy to build LLM applications. Let's go to the debating models. So now this one actually debates. You can introduce debate instructions too, or you can remove them and just let models be themselves. For example, let's do it like that. And if you just wanted to, let the models debate GPT-4, Sonnet, and Gemini. And when we run this, We enter a number of rounds, let's just say 2, and now we ask a question. Let's ask which is better, Django or Next.js. All three models are initialized. At first, OpenAI responds, and then second, Anthropic, and then fourth, OpenRouter. And while this is happening, we are actually writing the debate responses, as you can see, in real time. And eventually, we're going to have a final model, which is going to actually summarize this for us and make a decision. Here we go. We are at the final round. And here is the conclusion. Given the context of modern web development, Next.js comes out as the winner. I also built the coding agents.py. Again, very simple. In under 200 lines of code with error correcting code execution. When we run this, I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. And actually, it prints that this is going to execute code automatically for error checking. So we do need to accept the risks. So it has two options. We can generate new code or actually continue from an older project. This creates only single file projects. So let's actually generate. Let's ask it to generate a Tetris game and Pi game. And let's do 3 rounds. And we enter a file name as well. So now they're actually going to discuss now OpenAI and then Claude and then Gemini will discuss this. And finally, we will write it to file. And then we will go into error correction with code execution to make sure that our game is running without an issue. So since this actually builds single file applications in its current state and the maximum context output tokens is 4,000, that can become an issue for really large files, but just keep that in mind. So now the first round is complete. Now OpenAI, we went on to the second round. While this is ongoing, I can actually maybe talk about the requirements real quick. This only requires OpenAI, Anthropic, and term color. I have included a README file for each of the complex projects, plus a README file for the unified.py. You can read through, as you can see. It has multi-provider support, seamlessly integrates OpenAI, Anthropic, and Openrouter, flexible model selection, asynchronous and synchronous operations. It has a stream mode. You can enable or disable. It has automatic chat history management, system message, dealing with both OpenAI style system messages and Anthropic style system messages. It's all handled for you automatically. You can also use JSON mode with JSON mode enabled models, especially GPT models. It has a retry mechanism that will actually retry if you get an error from API up to 10 times and with a 1-second wait. You can set max message words so to limit the number of words per message for more concise interactions. I'll show you how you can do that. You can just set it here. For example, max history per message, you can set 100. So this will be a soft message in the prompt you're sending to LLM to limit its response to a maximum of 100 words. You can also set max history words, and we will automatically trim the message history so you don't incur too many tokens. Maybe it's by default set to 10,000. Okay. Our agents are still deliberating and debating. I think we are in the final round. Yeah, final code generation. It generates a file name plus the code block in between code XML tags. Like I said, we will be reviewing the code for all of these, especially unified.py, but you can download the code files from my Patreon. Link will be in the description. Okay, this is what I was talking about, actually. It just reached this maximum output token since it was writing too much code. This is like a good problem, I suppose. So we can actually create this. So since this was too long, it actually cut off and we couldn't get the concluding XML tag. This usually happens if you let it run, let the agents design the program for a longer period of time. Let's do this again, but this time we'll only give just like 2 rounds and the file name. while this is ongoing, I actually copied the previous short code, and I am actually going to copy this entirely and select the last part of it, and I'm going to do Control K, and I'm going to say, please conclude this using cursor. Let's see if this, because I'm really interested. So as you can see, it wrote about 336 lines of code, which equated to, give or take, equated to about 4,000 tokens. That's why it got cut off. Okay, it's going to have some difficulty doing it, but we'll just wait for the new game to be written. We are at the final code generation phase. It's actually, it wrote the Tetris.py, and actually the game ran without any issues. Here we go. So this works well. It's going to say code executed successfully. So there was no error. So this was very good. It wrote approximately 281 lines of code and no errors. And Tetris is a difficult game to make. So now let's take a look at the three model response chat. So this one actually gets responses from all three providers, from all three models, and then sends it to final GPT-4, I believe, or yeah, to final GPT-4 to actually combine the best elements. So this is like a chat where we get responses from all models at the same time and combine them. So we can ask what is async briefly. So we are getting responses in parallel from three models, and now we're combining the responses. Here we go. So this is a good way to combine multiple model responses, and there's no limit to how many models you want to use here. Now, lastly, we have, oh, I forgot to mention that coding the team discussions are saved to a JSON file as well, so you can actually read through them. This was when we were building the Tetris game. And lastly, the three model response single eval. This again does just like the three model response chat, gets response from three models, and then allows a single model to actually evaluate it and writes it to file. For example, let's run this. And I have another version of it where we get responses from three models in parallel, and then all three models actually evaluate it. Let's again ask what is async briefly. As you can see, they all are printing at the same time colorfully, because you can actually specify the color of with the chat. You can actually pass in the color parameter for term color. But anyway, the final model is getting a response in a JSON mode. It thinks that GPT-4o thinks GPT-4o actually gave the best response. This is the reasoning. It also provides a combined answer as well, and then talks about the differences. So this is when this happened, and that's why I actually created the three model evaluation. And you can actually see the response eval.json. This is what GPT-4 said. This is Claude 3.5 Sonnet. This is Gemini 1.5 Pro. And you can see the final evaluation. But then when I ran the same thing, but if I got all the responses evaluated with three models, look what happens, which is very interesting. Okay, now we are evaluating with three models. And it again saves it the response eval.json. So here we go. We can see each responses and evaluations. Look, OpenAI thought the best, GPT-4 thought the best response from GPT-4o. Actually, 3.5 Sonnet thought the best response was from itself, and Gemini actually thought the best response from itself. So this is really, I didn't expect this, but this is what happened. Take it for what it's worth. But this pretty much concludes all of this. Let's move on to the code review part. But like I said, code files for this will be available to download at my Patreon. Full everything will be available for architect patrons, and just the unified API with the simple use case will be available for connoisseur level. Okay, let's begin by reviewing the code for the main unified .py file. We have all of our imports. We import both OpenAI and async OpenAI, Anthropic and async Anthropic to use. We're going to use both of them. And we don't need to import anything from OpenRouter. It simply uses OpenAI with a different base URL. Here we start our class, and its initialization parameters can take a name. So you can customize its name. You can pass an API key. This is when you initialize it like this, right? You can pass all those things here, like argument. Mix history words actually allows you to set a limit on the conversation history. It's default set to 10,000. Mix word per message is a soft instruction to the model to actually the limit the single message that we receive from the model to a certain amount of words. And JSON mode is by default false. Stream is by default true. Use async is false by default. Mix retry is 10. This is if we get an error from API. We try this many times, waiting 1 second in between. Provider by default is anthropic, so it's going to be Claude 3.5's latest Sonnet. You can specify your own model as well, and should print is true immediately, but you can set this to false. So streaming messages won't print. This is useful, for example, if you when you're doing something like debating or something, you don't want to see all the responses. Or if you're doing async, for example, you can set should print to false. You can also set should print to false within each individual, for example, with each individual chat call. You can set it to false, so it won't print. Okay. So if we get the provider, if provider is OpenAI, we can set the model that is defined in the parameter. Otherwise, it's GPT-4o. So this is how we set the models. And we just assign all the parameters to keys, API key history, all of that. So the system message is you're a helpful assistant by default. But if the provider is OpenAI and we enable JSON mode, then we automatically add to the system message, please return your response in JSON. You can specify your own system message, but usually if you don't specify the word JSON in the system message when you're using JSON mode, then you're just going to get an error from the API. So this eliminates that. We initialize the client. If should print. I'm sorry. I actually made a mistake. This should print is actually correct, but actually the should print in it, which is up here, is actually to print the configuration of the class, such as the name of the class, which model, which provider, like the arguments that we're setting up by here. You can set it to false because imagine if you're using async, such as when we were getting responses from 3 models, maybe you're getting responses 100 times, right? You sometimes don't want to see that red class initialization printing. So that's why you can actually set this to false. And that is what we are checking. We get the API keys for different providers, initialize all the clients. If use async is true, then we initialize async. Otherwise, we initialize OpenAI. As you can see, for OpenRouter, we just change the base URL. Then we set the system. We have a method for set system message. Each one of these methods have an async counterpart as well. This set system message method takes in a message parameter. So you can set it yourself, or is by default, you're a helpful assistant. And we again do the JSON inserting of the JSON system message here. So essentially, this is what I'm talking about, model.set system message. So you can set it custom yourself here. Next up is add message. You can use add message to, it takes in a role and content to add a message to the current history. You may want to use this by saying, if you want to add dummy messages, you can add as many messages as you like. Okay, just make sure that with anthropic, you don't add 2 consecutive of the same roles, then you're going to get an error. I actually forgot to check for that. I'll fix it in a later version of this app. But here, if there is a role user and self.mixedword is set, then we introduce this soft instructions saying that please use this many words or less at the end of the content. Otherwise, we insert the content directly as the role. And it has an async counterpart as well. You can print the history length, conversation history with this. There's an async counterpart. You can clear the history. And it is an async version. This is one of the most important methods. It just takes in user input because we're assuming that, so you can just call it like this, right? Just call chat with a simple message string, hi. Or in this case, it's supposed to be user input, right? Because we are doing message, I mean. Yeah, just like that. So it just makes it super easy to get a response. It automatically assumes the role is going to be user as an async. Trim history. This trims the history based on makes history words, except it won't remove the system message. And then get response takes in a color value and should print. This is the should print I was talking about. You can also pass in any kind of additional arguments such as mix token or such as top key and stuff like that. Whatever parameters that the API call takes. So mix tokens by default set to 4,000 unless you change it. So we do this max while tries is less than max retry. We try to call, say, OpenAI or Anthropic or OpenRouter, and then we try to stream the responses based on either whether it's OpenAI or Anthropic. So this is what I was saying. If should print, then we print the streaming responses. But you can set this in the get response, or you can set this with the chat. So get response actually doesn't take in a message, so you should mostly use chat, but you can also use add message along with get response because all this does is actually adds it to the history parameter attribute of the class. Yeah, so we automatically trim the messages and add the messages. Everything's handled for you. And if there's an error, we wait for 1 second and we retry up to 10 times. You can increase the sleep or the retries if you like. And then there's the async method. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. The color for these methods are automatically set to yellow, but you can change it. So this exactly pretty much does the same thing, except it's an async function. So we are awaiting, and the loop is async for loop. Other than that, it's the same. So that's it. So this is the Unified API class. Like I said, you can download it from my Patreon. Link is in the description. So now let's take a look at this multimodal chat. Here we are importing the unified APIs. This is the one which you remember you can select different models to chat with the same conversation history. So we pretty much import the unified API, get provider selection. We have a list. We enumerate when we print it, and then we allow the user to make a choice. That's it. And this chat is going to get the provider selection, create a history list, empty, and then it's going to create a unified API based on the provider. We set streaming true, and then we just print information, take user input, and then pretty much if the user says change as a command, then we call the get provider selection again. Other than that, and then we reinitialize the unified APIs one more time. Other than that, pretty much this is it. We're just calling the API chat async. You could have also called API chat. With the user input with color yellow, you can change this. That's it. The debating models is very interesting. This is the one where the models are debating each other. So use debate instructions is essentially, I thought, okay, so this is designed so that GPT-4, Sonnet, and Gemini Pro actually debate each other. So if you set this to false, then actually you won't use this debate instructions. I thought, you can set your own if you like. Okay, this is logical, empathetic, and cosmic. So these are just going to be assigned to models in the order. Here we initialize the APIs. This debate function is going to take in user input, providers, and number of rounds and initialize all the APIs. Taking a debate topic, initialize debate responses, and then debate instructions. And then we initialize a debate data dictionary to save to a JSON file. And then we make a loop as many rounds as there are. We are going to loop over the APIs and print information and prepare the system message. We insert the debate instructions if use debate instructions. Otherwise, we keep this empty. Other than that, this is the debate system message. Continue this debate. Consider the points made so far, so on and so forth. We assign the system message, and then we also join all the responses into a full debate like this, and a bit less comprehension and all that. And then we just pretty much wait for the response. We enter the debate topic, and the debate so far, we give the full debate. And then we assign, once we get a response, we add it to debate response. And then we have the round responses for that round, and then we save it to debate responses. And then once the debate is done, this for loop is done, then we have another call to make to OpenAI, that you can change it with a final prompt based on this debate, provide a final conclusive brief explanation. And I did say that in the final conclusion, you must pick a winner. The question included comparisons such as Django versus Next.js. Yeah, you feel free to change it. Then we just simply initialize the class and just call it. That's it. The rest of it is just regular Python stuff. We get the debate data and save it. And our main function is going to have a list of providers and allow user to select number of rounds. And in that, with a while loop, we take in user input and simply call debate. That's it. Coding agents is very interesting. So first of all, we have a function that prints that the script will automatically execute generated code. And we ask for confirmation. We call that function. Coding team discussion takes in a project description, number of rounds, file name, and skip generation, because we can use this to actually continue from an already existing file to directly go to the error correction phase. We create a coding team discussion.json. We initialize it. So if you're not skipping the generation phase, then we initialize all of our APIs. We prepare our discussion data. And there are rounds in the discussion, we call each one with the system message. You're a developer in coding team, discuss the project, propose ideas. So this system message is going to let them discuss. We set their system message, prepare the full discussion, and just simply get a response calling the API.chat async function. And then prepare the round responses, and then save it to file. And in the final round, we're saying that you're the lead developer based on the team discussions, generate the final code. It's going to return a file name plus the full code. And we set its system message, and we pass in project description into the final prompt. And team discussion so far, generate the final code based on the discussions. We simply call .chat async from the unified class. And then we extract the file name and the code using regex, and then we just simply write it to file. Also prepare the JSON stuff and write it to the coding team discussions. Other than that, so we are writing it to file and whatnot, but then we set max attempts 10, and we create a loop for that, and we use subprocess to execute the file. If it's executed successfully, we print it. Otherwise, if there's an error, we increase the max attempts, and we also print the error from the terminal to the terminal. And then we initialize the error correcting class, which is going to use Anthropic. And the error correcting system message is to analyze the given code in the code message. We set the system message, and here's the error correcting prompt. The following code produced an error. This is the code. This is the error. Please provide a corrected version. We do say that to return this in code XML text, corrected full code, always return the full code, otherwise it'll try to redact. And then we simply call the error correction API, which we have initialized up here, right? Again, we are using our unified APIs. This get response is going to take in a user input and all the providers. And we create an async task list for provider and providers API. We initialize each one. And see here we are using the should print init false so that it doesn't clutter up the terminal when the class is being initialized. And we append each one with the API.chat async, and then we gather it. Here's the combined responses, which is going to take in the responses from all three models. And then is we initialize OpenAI, because we're going to use GPT-4o for this. And the comparison prompt says compare and analyze the following responses from different AI providers in accordance with this input. Pass each response here. And then we ask provide a response combining the best elements from all responses in effect factual manner, we just call the chat async again. Like I said, we could have just called the chat as well here. And then we initialize the providers list and take in user input and simply get responses and then combine responses. That is it. Okay, thank you for watching. I hope you'll make good use of the unified API. I know I'm really excited about this. This just makes it just so much easier. Believe me, I will be expanding this class as well. Like I said, all the full code files, including the complex examples, will be available at Architect Plus level at my Patreon. Link will be in the description. But just the unified API with the simple use case will be available for Connoisseur Plus level patrons. Also, in my Patreon, I have higher tiers on which I do consulting work, or if you just want to talk to me one-on-one, if you have any coding questions or need help with your project, consider those as well. I offer 1 hour per month and 3 hours per month in 2 different tiers. Also, I'm posting on X now. My handle is at hive_echo. And so just do follow me because I do have additional content there as well. But thank you for watching, and I'll see you in the next video. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.